Hi, today's seminar lesson, we're going to learn about unit circle. Okay, so the definition, the unit circle is a circle of radius, center, radius equal 1. I forgot to put it there, radius equal 1. And center at the origin in the xy plane. And the equation is x squared plus y squared equal 1. Right? So if you recall the equation of a circle, the regular circle is x squared plus y squared equal r squared, right? Equal r squared. And because we have a unit circle, unit mean 1, so this implies the unit circle has the radius of 1, right? So therefore, if I let r equal 1, you have that equation. Okay, so in the unit circle, we divide into 4 quadrants. So the first quadrant is we're gonna have we're gonna have a positive x and positive y. And so here's I have x is positive and y is also positive. Second quadrant, we're gonna have a negative x and positive y. Right? X is negative and y is positive. For the third quadrant, both x and y are negative. X is negative, y is negative. And on the fourth quadrant, we have positive x and negative y. X is positive, apologize. X is positive and y is negative. That is below the origin. Okay, okay, so let's jump into the a few examples. Show that the point square root of 3 over 3 and square root of 6 over 3 is on the unit circle. Now, one way we can approach this is we're going to use the definition of unit circle, right? So if you look it up there, we know that the unit circle have an equation of what x squared plus y squared equal 1. Right? And we know that this is my x and this is my y, right? So if you can show that x squared plus y squared is indeed equal to 1, then the point root 3 over 3, root 6 over 3 is on the unit circle, right? So let me just instead of xy, I'm just gonna write parenthesis here, parenthesis square plus parenthesis square equal 1. And I know my x is root 3 over 3. And my y is root 6 over 3. Right? Root 3 squared is 3. 3 squared is 9. Actually, I'm going to put a question mark here because I don't know is it equal 1 or not. Right? So let's see. The first fraction I have 3 over 9 plus root 6 squared is 6. 3 squared is 9. This is equal to 9 over 9, which is 1, right? So yes, the point square root of 3 and square root of 6 over 3 is on the unit circle. Okay, all right. Problem number 2, the point square root of 3 over 2 comma y is on the unit circle. So this problem, they say that the given point is on the unit circle and is in quadrant 4. Phi is y coordinate. So same thing, I'm going to use the definition of the unit circle. So start out x squared plus y squared equal 1. And x is root 3 over 2. Don't forget to square it. Right? Plus y squared is equal 1. Right now we can solve for y. Okay, now just algebra. Square root of 3 over 2 squared is 3 over 4 plus y squared equal 1. Subtract 3 both sides, so I have y squared equal 1 minus 3 over 4. Right? 1 is the same thing as 4 over 4. We'll multiply both top and bottom by 4. Right? So 4 minus 3 is 1. So this implies y squared equal 1 over 4. 4 minus 3 is 1 over the common denominator, which is 4. And then because we want we want y, so we're gonna take a square root both sides. When you take square root both sides, don't forget add plus and minus, okay? So y squared equal plus minus 1/2. Now, which values should I choose? We know that this point is in quadrant 4, right? So that means in quadrant 4, the y value is negative, right? There in quadrant 4, so y value is negative. So we're gonna choose the negative 1/2. So we're gonna choose y equal negative 1/2. And we're done. Okay. Terminal points on unit circle. So given a unit circle, I want you to know some terminologies before we jump into solving, finding angles and terminal points. Okay, so on the unit circle, an angles can have any real numbers measured. An angle is in the standard way if its vertex is as the origin. So here I have angle theta. Here I have angle theta, and the vertex is at the origin, which is right here. Maybe I'll denote it in, in green. Origin. Okay, the vertex is at the origin. The initial side coincide the initial side. The initial side, maybe I'll denote in yellow. The initial side is coincides with the positive x-axis. So here is, so if I want to draw my initial side, draw it. That's right there, my initial side in highlighted yellow. Okay. Initial side, right, is coincide with the positive x-axis. Okay. Positive angles are swept out in a counterclockwise. So so if maybe I'll denote in blue, positive angles are swept out in a counterclockwise direction. So if I sweep out a angle in counterclockwise direction, I'm going to have a positive angle. So if you look at the picture on the right hand side, so here's my angle theta, and theta is equal to 30 degrees, right? So let's sweep out a positive angle by start going up, right? Start going up. A negative angle is swept out in a clockwise direction. Negative angles is swept out in a clockwise direction. So again, same picture. If you look at that, the negative angle is being swept out in the clockwise direction, right? And start by going down. Okay. An angle can be denoted as theta, so the little theta, or alpha or beta. Okay, theta is more common though. Okay, but they can denote it by any Greek. Most usually for angles they use Greek letter to denote the angles. Terminal points is where the terminal ending side of the angle intersects the unit circle. So right there in the little black dot, that's my terminal point. And the blue line there you see is the terminal side. Okay, so here is, this right here is terminal side. So the intersection between the terminal sides and the unit circles is your terminal point. Okay. The terminal point has the coordinate. So here, the terminal point has the coordinate, an x value and a y value. By definition, psi theta is the y value of the terminal point, and cosine theta is the x value of the terminal point. Okay, so just remember, cosine, and then y is sine. Okay. So thus cosine and sine are just the x values and y values respectively of the points on the unit circle. Okay, so let's jump into the example to demonstrate what we was been talking about, right? So I want you to find the terminal point determined by each given angles. So the first angle is theta equal pi over 4. Right? If you have a hard time imagine your angle in radian, you can change it into degree, right? So if I want to change pi over 4 in degree, so I want to change pi over 4. We are writing black here, pi over 4 in degree. I want to eliminate pi. So, you know, 1 pi is equal to 180 degree, right? So 180 degree divided by pi. Cancel. 180 degree divided by 4 is 45. 45 degree. Okay, so if you want to change from radian to degree, all you have to do is multiply that by 180 over pi. Okay. Okay, so theta equal pi over 4. Where's pi over 4 on unit circle? So here is my theta. Right there is my theta, right? Equal pi over 4. So at pi over 4, my x value is root 2 over 2, and my y value also root 2 over 2. And also root 2 over 2. So the terminal side, the terminal point at when theta equal pi over 4 is root 2 over 2, comma, root 2 over 2. That's my terminal point, right? And then I'm gonna denote this in red. So that's point A. Point B is when theta equal 135 degrees, right? 135 degree is, again, we go in counterclockwise, right? Because they're giving you a positive angle, like positive angle. So 135 degree is right here. Now they know in blue, right? At when the angle equal to 135 degree, my x value and y value is negative root 2 over 2, comma, positive root 2 over 2. Okay, so this is a point B. C, theta equal negative 3 pi over 4, right? So again, if you want to change that into degrees, all you have to do is you multiply that by 180 degree divided by pi, right? And it's going to be equal to, let's see, I have pi cancel. 180 degree divided by 4 is 45. 45 times 3 is 135, right? It's 135 degree. So if it hard for you, so if easier for you to remember, to imagine in degrees, if you change that into degrees, it's 135 degree. So negative 135. I'm sorry, negative 135, right? Okay, so remember, we're gonna go clockwise for negative angle, right? So if you take 360, subtract 135, you got 225. So right here, if I go clockwise, right there, that's negative 135 degree. Why? Because if you take 225, subtract 360, you got negative 135 degree, right? All right, so right here is point C. C, I have negative root 2 over 2, negative root 2 over 2 for x and y. So negative root 2 over 2, comma, negative root 2 over 2. Now, alternatively, you can find the point C by just do the projection of the positive angle. So they're asking for the negative 135 degree. Well, we know the positive 135 is right there, is that point B, right? That's the blue dot right there. All you have is do the little projection. If you project it down, over the x-axis, that's the negative 135. Okay, that's a different way of finding a negative number. Right? Okay, so and then the last one, the angles given is negative pi over 3. Okay, so we're gonna do the projection thing. So pi over 3 is right here. Pi over 3 is right here. Maybe I'll do in the last point. Maybe I'll do in black. Maybe, yeah, I'll do in black. So pi over 3 is right. Well, I don't want to do that. Pi over 3 is right there. I want negative pi over 3, right? So we project it down over the x-axis. Is that one, right? So it's pi over 3. So this is equal to, this is equivalent to 5 pi over 3, right? Which is, the x is 1/2 and the y is negative root 3 over 2. That's my terminal point values. Right? Okay, let me erase these, make it a little neater. And that's how we find terminal points for the given angles on unit circle. Okay, thank you for watching.